Good day, students. So in this clip, we're going to be going over some examples that will help you master the difference of squares. Now, what we're going to be doing is we're going to be going in two directions. We're going to be factoring where applicable and multiplying where applicable, okay? Because when you go back and forth between factoring and multiplying, it'll help you master the whole process of factoring difference of squares. Alright, so let's go ahead and do the following problems. So the task is either we factor or multiply. Alright, if it's in factored form, we multiply. If it's in an expanded form, we factor. Alright, so number one. What if we have x squared minus 16? Alright, let me write that again. Or if we have x squared minus 16. Remember the formula for difference of squares is a squared minus b squared equals a plus b times a minus b, alright? All you do is you root the first and the last, and then you add and subtract what you get. Alright, so you root this and root that and do the plus and the minus. The plus will give you this quantity right here, and the minus, the difference, will give you this quantity right here, okay? So that's what we're going to do here. We're going to root the first and the last, and then we're going to do plus and minus, okay? Alright, what is the square root of x squared? Square root of x squared is x, so we have x plus 4, because the square root of 16 is 4, and x minus 4. Alright, so there goes the factored form. Alright, so there you have it. Okay, let me just box this one so you see that that's the answer. Now let's try another example. Example 2. What if we had x plus 1 times x minus 1? We can clearly see that this is already factored, alright? So if we multiply, what is it going to become? It's going to become the difference of the squares, right? We're going to square x and then we're going to square 1. So it's going to basically become x squared, which is the first term that shows up in the two quantities, minus 1 squared, because that's the second term that shows up in the two quantities, alright? So if I work that out, I'm going to have x squared minus 1. Alright, so that's the answer to number 2. Okay, now let's move on to question number 3. Question 3, we have, we're going to do x squared minus 25. Alright, this is already an expanded form, so we want to factor this, okay? Remember, we just root the first and the last, plus or minus, that'll give us the result. So I'm going to root this and root that, and I'm going to do the plus, the sum and the difference of the square root of both terms, alright? So the square root of x square is x, and then the square root of 25 is 5. So I'm going to do the sum first, x plus 5, and then the difference, x minus 5. And that's the answer. That's the factored form of x squared minus 25. Alright, let's try another example. This will involve multiplying. So number 4, what if we have the factored form a plus 4 times a minus 4? Remember the difference of square formula? You square the first one minus the second one when you're multiplying, alright? So the first term that we have is a, so we're going to have the first term squared minus the second term squared, alright? So if I simplify this, it's going to be a squared minus 16. Alright, number 5, we're going to go the opposite direction. What if we have x squared minus 121? This is an expanded form, so we want to factor. So how do we do this? Same process, you read the first and the last terms, and then you do the plus, the sum, and the difference, alright? The square root of f squared is f, so we're going to have f, and then the square root of 121 is 11. We're going to have the sum of the roots times the difference of the roots, like that. And there goes your answer for number 5, alright? I mean, box 4 is the answer for 4, and then goes the answer for 5. Alright, so for let's go to number 6. For number 6, we have h plus 3 times h minus 3. This is already factored, so we're going to multiply. So we're going to have the first term squared minus, remember, difference of squares, the second term squared. If I work this out, I'm going to have h squared minus 9 and that's going to be my final result. Alright, let's move on to number 7. For number 7, we have w squared minus 100. This one is in expanded form, so we want to factor using the difference of squares formula. So all we do is we root the first and the last, root this, root that, and then we're gonna add and subtract the square root, okay? So the answer for this is going to be w, and then because the square root of w squared is w, and the square root of 100 is 10, so w plus 10 times w minus 10. And there goes the factored form. Alright, now let's move along to question number 8. Question 8. What if we have x plus 7, the factored form x minus 7? What is the expanded form of this? Since this is a factored form of the difference of squares, if we want to multiply this, it's going to be the first term square minus the second term square. Okay? If I work this out, the square of x is just x squared, and then the square of 7 is 49. And this is the factored form of x plus 7 times x minus 7. Okay, now let's move on to question number 9. Now what if we have 9x squared minus 4? This is the expanded form. We want to factor this using the difference of squares formula. So what we're going to do is we're going to use the same procedure we've been using previously. So we're going to root the first term and the last term, and then we're going to add and subtract the square roots. Okay, so what is the square root of 9x squared? It's 3x. What is the square root of 4? 2. We're going to add the difference, add the roots, and then we're going to subtract the roots, 3x minus 2. Okay? Because when you're taking the square root of 9x squared, what you're doing is you're rooting 9, and then you're rooting x squared individually, right? So since 3 times 3 is 9, the square root of 9 squared is 3, and then the square root of x squared is x. So that's why I have 3x here and a 3x there, because the square root of 9x squared is 3x. Alright, so there goes your factored form. Alright, now let's go look at a problem that involves multiplying, number 10. What if we had 3x plus 5 times 3x minus 5? So since this is already factored, what we're going to do is we're going to multiply, okay? So if we use the difference of squares trick, what we'll notice is that all we just do is we take the first term square minus the second term square. Okay? So you gotta be careful here. When you square in, this square has to affect both the 3 and the x. Alright, so you're gonna have 3 squared times x squared, right? And then if you square 5, you have 25. So 3 squared is 9, so you're gonna have 9x minus 9x squared minus 25 as your expanded or multiplied form of 3x plus 5 times 3x minus 5. So if you expand this, you get this. If you factor this, you get that. Alright, moving along to question number 11. 11, we have 16 n squared minus 1. So for this one, it's a factored form, so it's a expanded form, so we have to factor. So to factor this, since this is a square and that is a square, we're going to root the first term and root the last term. We're going to add and subtract the square roots, okay? So what's the square root of 16n squared? It's 4n plus the square root of 1 is 1 times 4n, the difference, minus 1. And this is your factored form, okay? There you have it. Alright, let's move on to question number 12. Question 12. What if we had the problem 5m plus 2 times 5m minus 2? Now, this is a factored form, so we want to multiply, right? So using the trick we just did, all you just do is you take the first term squared minus the second term squared out. Okay? So when you're squaring 5m, you're going to square both of them. You're going to have 5 squared and then m squared. Okay, minus 2 squared is just 4. So this comes out as 25 m squared minus 4. So this is the multiplied form of this factored expression right here. Alright? So don't forget, factoring is the opposite of expanding or multiplying, right? Okay, let's move on to question number 13. So, for question 13, what if we had 64 n squared minus 36 n squared? How do we do this? Same process. Since you have a difference of squares, we are going to factor here. Alright, so how do we factor that? You simply root the first and the last, and then you're going to add and subtract square roots. Okay? So what's the square root of 64n squared is 8n, plus the square root of 36m squared is 6m. So this is the sum. And then we have the difference, which is 8m minus 6m. Okay? Note, when you're rooting this, you root the 36 and the m squared independently, so you get 6m, and then the 64n squared, you get 8n and 8n, okay? I made a slight mistake here. Let me fix that real quick. This is supposed to be 8n. 8n. So this is 8n. Alright, so there you have it. Alright, let's try another example. Now, what if we had number 14? What if we had 9t squared? Oh, I'm sorry. What if we had 3t plus 2s times 3t minus 2s. This is a factored form, so what we're going to do here is multiply, alright? So how do we multiply this? We can use a shortcut instead of foiling, since it's the expanded form of a difference of squares. We're just going to take the first term, 3t squared, minus the second term, 2s squared. Alright? So remember, when you're squaring the product of terms, you distribute the square to both terms. Alright? And then these two get distributed to this square gets distributed to the 2 and the s. So you're going to have 3 squared t squared minus 2 squared s squared. Okay? So the answer becomes 9t squared minus 2 squared becomes 4s squared. And there goes your final result. This is the expanded form. Alright, now let's move on to question number 15. What if we had 9 over 4 x squared minus 16 y squared? We're going to factor this one, right, because this is the expanded form. So all you do here is we're going to use that factoring trick I showed you before. Since this is a square that's a square, we just take the square root of this and that. First and the last term, you're going to add the square roots, and we're going to subtract the square roots, put them together, and that will be that. Okay? What on earth is this? 9 over 4 root 9 over 4. That looks too complicated. So let's see what we can do with that. Square root of 9 over 4, we need to break it down into the square root of 9 divided by the square root of 4. This is the properties of radicals, alright? So this becomes 3 over 2. Alright, so that's not that bad anyway. So let's do it. So if I square root 9 over 4, I'm going to have 3 over 2. And when I root x, so I get x. So that plus 4y. Then we're going to multiply it by 3 over 2 x minus 4y. Alright, and that's the factored form of the expression we just did. So there you have it. Okay? Alright, let's try one last example, number 16. What if we had 2 over 5t plus 3 over 7s times 2 over 5t minus 3 over 7s. Okay? This is a sum of difference of squares. How can we expand this using the shortcut we just learned? All we just do is take the first term, 2 over 5t, and we'll square it, minus the second term, right? The second term is 3 over 7, 7s, and we'll square that, okay? Well, I don't need that parenthesis there. I don't know why I put it there. All right, take that out of there. Okay, so let's do this. Now remember, when you're squaring multiple terms, that square has to be distributed to both terms in the parentheses, like that, and then this gets distributed to both of them, all right? So how do we work this out? This becomes 2, the fraction 2 over 5 square, t square, minus the quantity 3 over 7 square, s square, all right? Now, what is 2 over 5 square? You just square the top and the bottom, right? So you're going to have 2 square over 5 square times t square minus 3 square over 7 square times s square. All right? So we're going to be squaring everything top and bottom. So here we're going to have 2 squared is 4. And then when you square 5, you get 25. 25t squared. Minus, when you square 3, you get 9 over 7 squared is 49 s squared. Alright, so there goes the expanded form of the expression. And there goes the answer. Alright, so thank you so much for paying attention to this presentation. Please subscribe to my videos so you can get future updates and help support the production of more videos. Share with your friends if you liked it. Small collection of clips can be found on mathgotserved.com. Thanks again and have a wonderful day.